Me clearly? Is everyone hearing me clearly? Okay, thank you so much. I want to welcome you to my lecture today, and I want to welcome you to week 3. But before I get started today, uh, I want to tell you that the assignment 1 will actually be graded today, and of course, the solution to that will also be uploaded as well. I need you to check the canvas for update. And you know what? On Tuesday, I'm basically going to walk you through midterm 1 practice questions. And I'm also going to give information about what the expectation is going to be regarding the midterm 1. But today, I want to welcome you into another exciting topic. And of course, give me 1 second. I'm actually going to share my lecture slide. Okay, like I said, today the focus is basically going to be on another exciting topic in statistics. And of course, the focus is going to be domain variable. Okay, we want to talk about situation where we have domain variable as a predictor. Okay, so how can we actually run our regression? You remember the other time I started by walking you through how to characterize relationship between two variables. Of course, the nature of the predictor variable we've been dealing with is actually continuous, but today we want to focus on a situation where the predictor variable is basically going to be categorical. And, you know, when it is categorical, of course, we actually going to be calling that domain variable. And of course, I'm basically going to walk you through how that can be implemented. Okay, so the goals, you know, for today, at the end of the lecture, you'll be able to understand what a dummy variable is, and you're also going to learn how to fit regression model with dummy variable as a predictor variable. Like I said, that is going to be the focus today. Okay, now let's get started. Okay, so what do we actually mean by domain variable? We actually, you know, you know, when something is designed, to resemble and serve as a substitute for real or usual thing, okay, or a counterfeit or a sham. Okay, that's a dummy variable. I'm going to tell you now. This is a situation, okay? We want to look at I'm going to give you an example now. If I basically want to look at the effects of gender on salary, okay? The gender is actually categorical. I said that you are male or female, and because the nature of the predictor variable is categorical now, we're actually going to use a dummy. We're going to assign values 0 and 1. We can decide to say, okay, you know what, we're going to assign 0 for male or assigning 1 for female. We can at the same time assign 0 for female and 1 for male. Okay, assigning 0 or 1 does not actually say a particular level within within this categorical variable as a numerical advantage. That is not what we mean. Okay, the one we actually assigning 0 number weight is just trying to make that as a kind of reference. We can decide to make male as a reference. We can decide to use female as a reference as well. We actually need to decide on that. So what I'm trying to tell you now, okay, for, when you have a categorical variable, of course, the categorical variable has levels, at least two. For gender, we actually have two levels. Of course, we're going to use 0 or 1. We're going to use 0 for a particular level within the categorical predictor variable, and we're basically going to use 1 as well. Oh, let me also tell you this. We can also have situation where the numbers of levels is more than 2. If I want to look at the effect of race, okay, if I want to look at the effect of race, okay, on salary of professional workers, of course, race is expected to have more than 2 levels. Okay, in the United States, I can talk about the whites, the African American, the Latino, and so on like that. Okay, so in that kind of situation, we may basically we're going to have more than 2 levels, and having more than 2 levels, what we basically going to assign maybe beyond 0 or 1. So I just give you an example now. Okay, so like I said in this example, because gender is categorical, okay, male, male, we assign the 0 and 1 to male and female. We can decide to assign 0 for male, 1 for female. We can do that vice versa. Like I said, assigning a 0 to a particular level within the categorical variable does not mean, okay, that is inferior numerically. That doesn't mean that. That is just for labeling. Okay, that is just for labeling. It's not as if the one you assign with figure 1 is actually better than the one you assign with figure 0. It doesn't go that way. Okay, it's just for labeling, like I said. Okay, so I want to go into an example now. Maybe we have a research question, and we want to look at what is the relationship between wage and marital status in 1985. Okay, why do we say 1985? Because the data set that we actually want to use is from 1985 current population survey. I want to tell you now, this may not be binding in today's world, because this very data set that I want to use here is far away. There's possibility, that if we really want to know, there's possibility, things are changing. We live in a stochastic environment. We live in a probability space where things are changing. We could actually update this data set, up to date, and trying to see what is actually the role played by marital status in wage. Okay, but based on the data set that we have right now, we basically want to look at the effect of marital status on wage. The marital status is actually the predictor variable here. And you know what? It is categorical. Categorical in the sense that has more than 1 level. And of course, the wage is continuous. Okay. So here now, this is an example of a domain, where the domain regression is basically going to hold, because the predictor variable is actually categorical. Okay. So take a look at that. Okay. So like I said, we actually going to use X to denote status, the marital status, and it is binary. Take a look at that. It's either you are married or you are single. Okay, and Y, we use Y to denote the response, and the response is actually hourly wage in dollars. Okay, what do we want to do here? We actually want to see whether somebody who is married or a worker that is married or a worker that is single, whether they basically going to have the same wage. Okay, we want to see if there's going to be a kind of significant difference in the wage obtained by the married and the single worker. And using the dummy regression now, we actually want to look at the effects of marital status on wage. Now we have data set. We have data set here now. Okay, we have data set here now. Okay, we got wage, we got status. Okay, that we have collected from the professional workers. If you look at the number one, this is a married worker, and it's actually getting $9 per hour. Okay, and we have another married person here that's collecting $5.50. We have single that's collecting $3.80. We have married that's collecting $10.50, and so on like that. And you know what? The very first thing we basically going to do, we can actually have a diagrammatical plotting of wage against status. And don't forget, the status is actually categorical. We got married, we got single. When you take a look at what I have now, this is like having a box plot. Okay, we are plotting wage against the marital status. If you take a look at the very first box now, this is for married and this is for single. Okay, I don't know whether you've seen that before. That is what we call a box plot. Okay, in a box plot, you're basically gonna have the minimum value, you're gonna have the maximum value, you're gonna have the first quartile, the middle quartile, and the third quartile. Take a look at that. Take a look at what we have now. Okay, take a look at that. Okay, now that is a plot, but there's something that I wanted to say. When you decide to compare the middle now, based on the preliminary investigation that we have now, you're basically going to see the married person actually had more than the single. I wanted to say now, when you compare, the middle, the second quartile of the box, of the box plot of the two levels within the marital status, okay, you can actually see that one is greater than the other one. So take a look at that. Okay, now this particular data set was actually adapted from Dr. Alicia Johnson's course material, and the Johnson Alicia is an associate professor at Macalester College, Minnesota. Okay, that material is very, very useful. Now, let me tell you this. If you have a data set, CPX, okay, and we want to fit a linear regression module to that, let me tell you, R will automatically assign 0 and 1 to status. I'm going to say that again. You do not need to be manually assigned 0 and 1 to the categorical predictor. The R software will automatically handle that for you. Can everyone confirm again if you are still hearing me clearly? Okay, thank you so much, and thank you for confirming that. I want to repeat what I said. At the beginning, I told you that when you actually want to run, when you are working with a categorical predictor variable, predictor variable that have two level, that have a more than one level, of course, you basically gonna assign 0 and 1. You're actually going to decide on how to do that. But you know what? When you are using an R software now, You don't need to do that. The R software will automatically do that for you. Okay. Now, if you have your data set in R, okay, if you have your data set in R, okay, I walk you through several ways, to import data set into R. If you actually have a web link, you can just copy that into R, you attach, and you're basically going to have access to that. If you have data set in a format, what you just need to do is to save that in the CSV comma delimited. And when you do that, you now import that into R using the code that I walk you through. If you need more information about that, I will need you to watch my video, lab 1 and lab 2 video. They are published on Canvas. But right now, I'm actually going to be assuming now, okay, that you basically already have your data set in R, which you actually call CPX. Okay, you all need to just write a code. Okay, MOD equal to LM on wage on status. The wage here is continuous variable, and the status is a categorical predictor. Like I said, our software will automatically choose level of the predictor variable to assign 0 or 1. That depends on what you see in the output. Now, I want you to take a look at the output now. When you actually do summary mode, you're basically going to have this output. And there's something I want you to pay attention to in the output. Okay, in the output, you're basically going to say this guy, you see status single, right? Now, when you see status single in your output, it means our software has automatically coded single as 1 and married as 0. I'm going to say that again. If you take a look at your output, your arrow output, if you actually see status single, it means automatically arrow software has coded single to be 1 and married to be 0. Now, coding married to be 0, it means is actually using married as a reference, okay? And in other words, if you maybe in another analysis, if what you see in the regression output is status married, if you see status married, then it means our software has automatically coded married as 1 and single as 0. But the one I'm showing you now, as you can see in the output, of course, is actually coding, arrow has automatically coded single as 1. And of course, it coded married as 0. And I told you the other time, coding, a level of a predictor variable receiving 0 or 1, but that doesn't mean the one that received 1 is better than the one that received 0. The one that receives 0 is actually being used as a point of reference. I wanted to take note of that. Now we have our result now. Like, if you look at the estimate now, okay, we have the intercept, we have, this is the beta node now, okay, and this is the beta 1, okay, and of course, don't forget, we also have the standard error associated with each of the estimate. I told you the other time, right? The standard error will tell us how reliable is the estimate. And of course, the t-value here is basically when you are trying to conduct a test of significance on either beta naught or beta 1, you actually going to conduct a test statistics, and which I walk you through on Friday. Of course, the test statistic here is basically going to be the ratio of the estimate to the standard error. And of course, the next thing, the p-value here is just the p-value associated with the test statistic. And of course, if you want to take a decision on whether the beta naught or the beta 1 is significant, what you're basically going to do is to compare the p-value with the level of significance. Okay, so I wanted to look at the output now. So the output, the result you're actually going to get, the output is going to look like any other regression model, so take a look at that. Okay, so I'm going to extract something out now. Okay, what I want to extract out is basically this guy here. Okay, and that is what you see right here. Okay, you can see that now, right? That's what you see right here. And based on this output, okay, so how can we actually write the fitted regression model? Okay, so this is a fitted regression model. Okay, you remember what we normally write: y cap equal to beta naught cap plus beta 1 cap s. Our y is actually the wage that we basically want to predict, and our s is actually the status. And the reason why you have a status single is because the R software has automatically coded single as 1. So that is a model now. Okay, what you see now is basically how you can actually write a fitted model from the output. Take a look at that. Now we have the regression model now given as that. Now the question now is how can we actually going to interpret the parameters in this regression model? Okay, when you take a look at this now, okay, if you want to interpret the intercept, how are we going to interpret the intercept? You know what I mean? You remember in your high school, right? You remember in your high school, where you talk about y-intercept, right? The y-intercept is more or less the values of y when s equal to 0. I think you remember that, right? Okay, so here, when the status equal to 0, okay, don't forget, when the status equal to 0, I'm actually referring to married, right? When the status equal to 0, this guy is going to go, I'm only going to have $9.40. So it means that is the wage that on average, okay, when the status single is actually 0, which means I'm talking about the average wage of a married worker per hour. Okay, that is $9.40. That's what I mean. Okay, $9.40 is actually the average wage. Okay, now what is the meaning of negative 1.09? Okay, the negative 1.09 now is basically the regression slope. And if I want to interpret that now, I'm basically going to say when you move from the status from married, okay, movement from married to single, if you move from married to single now, okay, of course, the expected wage is actually going to go down by $1.09. That is what I mean. So if you take a look at what I have now, you're basically going to see on average, single worker hand less than married worker by $1.09. And of course, you can actually see from the box plot that we actually consulted here. Take a look at that. That is for married. That's like a $9 something. And this is for single. That is less than that. So that analysis now actually confirm, this. Okay, so take a look at that. There's an agreement between them. So take a look at that. So that is what the model is actually talking about. You remember in your high school, if you basically want to interpret the slope, you're going to say for every unit increase in X, okay, for every unit increase in X, you basically want to look at the corresponding increase in Y. But what we're trying to tell you now is when you move, when a worker move, when we're trying to move from status singles to status, from status married to single. Don't forget the married is being referenced. Don't forget we coded married as 0. We're using that as a reference, okay? So which means movement from married to single, we actually take $1.09 from the average salary. So this is trying to tell you now, the married worker actually have more, per hour compared to single worker, okay? But there's something I want you to see now. Do you know what we're trying to do in linear regression, particularly when you have a categorical predictor, is similar to what we're doing in test of test of equality of means. You remember before now, you've learned how to compare two groups, right? In statistical analysis, where you make use of a t-test, you remember test of means, right? Test of means. What I'm trying to tell you now, what we're doing now, using a dummy regression, is actually synonymous with comparing means of two groups. Okay, don't forget here, how is it similar to that? It's actually similar to that because you're actually comparing the salaries of male and of married and single. I'm going to say that again. How do you compare the salaries of married and single workers? Of course, in statistics, you use a t-test for that, provided if assumption, underline the use of t-test. Oh, okay. But you know what I'm trying to tell you now? What I'm trying to tell you now, okay, you are, if you take a look at this guy now, the difference between this guy here is actually talking about average salary of single worker, average salary, okay, average salary of single worker, and this guy now, average, okay, salary of married worker, of married, okay. But don't forget, we have a way to carry out if there's a significant difference between two means, which you have done before. But what I'm trying to tell you now, it is the same thing as a beta one, the beta one, which is the slope, okay, which don't forget, which means if I want to conduct a test of significance on, if you watch my video for Friday, when I want to test the significance of a beta one, whether beta one equal to 0 or not. If beta one is equal to 0, you know what that means? If beta one equal to 0, is trying to say there is no significant difference between the average salary of single workers and the average salary of married workers. That is what it means. And if if you look at the alternative, where beta one is not equal to 0, you know what that means? Okay, what that means is the synonymous is actually implies that there is a significant difference between the average salaries of married workers and single workers. That's what it means. I just wanted to take note of that the dummy regression we're doing now is synonymous with the test of means in statistics, where you use t-test to test if there's a significant difference between two group of means. Okay, I just wanted to take note of that. Okay, and you know what? Testing whether beta one equal to 0 is equivalent to sample t-test, where you are testing whether the mean of the mean salary of the married workers is actually equal to the mean salary of a single worker, which I wanted to take note of that. And you remember in statistical analysis, you're going to construct a t-test, right? For that, if you want to look at what you've done before, where you basically going to, the numerator is going to be the difference between the average of the two groups divided by this, the standard deviation, then the square root of 1 all over the sample size, the sample that you choose. That will be the numbers of married workers, and NS is basically going to be the numbers of single workers. And of course, we're basically going to have this as the test statistic value. And at the end of the day, we're going to have a p-value. But let me tell you this, we have a way to do that in R. When you actually have two groups, okay, where you add some values here, you add some values here. This is for single workers, and this is for married, okay. In R, if you do a t-dot test, okay, t-dot test of single comma married is basically going to give you an output where you're going to see a p-value that you're basically going to compare with the level of significance. And let me tell you what we're doing here. What I'm trying to tell you now here is that this is the same thing as testing for beta 1 equal to 0 and HA testing that beta 1 not equal to 0. I want to tell you they made the same. Okay, they made the same. And don't forget, if you want to test here, it's basically going to be the beta 1 to follow my video for Friday divided by the standard error of a beta 1 curve. Okay, and the p-value associated with the test is what you're basically going to compare with the level of significance. But let me tell you this, take a look at this. The p-value when you conduct t-test of independent means, the p-value is 0.02009. When you use the regression, dummy regression, let's see what you have as a p-value. Oh my God, look at that. 0.0201 compared with a 0.02009. If you approximate that, they are the same. Look at that. Mathematically speaking, it is mathematically observed, and statistically proven that when you actually conduct a domain variable regression, the p-value you're actually going to get will be the same as the p-value that you're actually going to get, here when you conduct a significant test on the beta 1. Take a look at that, which is going to be the same, which actually confirm that they are the same. Okay, the two tests are similar. That's what it means. Now, right now, when you compare this with a 0.05, okay, that I call the standard level of significance alpha, what is going to be your conclusion here is basically going to be you're going to reject H naught. Okay, because the p-value is less than 0.05, it means you're basically going to reject this guy, you're going to accept that guy. And also, when you are testing for this, okay, we got that same p-value. Don't forget what we're actually testing for is beta 1 equal to 0 and H alternative beta 1 not equal to 0. We are also rejecting this. We are accepting that. Let me tell you this. When beta 1 is not equal to 0, it also means the mean, the average, salary of married workers and single workers are not the same. It means there's a significant difference between them. Okay, that's exactly what I've walked you through now. Oh my God, that is going to be the end of my lecture today. Is there anyone who need clarification? Is there anyone who need clarification on this? So like I said, it's a question. And if there is anyone who want to ask question, if you really understand what I've presented today, I need you to say yes, or you comment yes. Okay, I think I've seen good number of people that say yes, but you know what? If there's anyone who doesn't understand, I'm actually going to wait for questions before I go. Is there anyone? Okay, so silence implies that you guys are good. Okay, this is where I'm actually going to draw my calling today. Like I said, tomorrow's lecture is basically going to be meet and one practice preview. I'm going to say that again. Tomorrow's lecture is just going to be midterm one practice preview. I'm actually going to walk you through, practice questions on midterm one. I'm also going to give you information about, what you should be expecting in the midterm, the area of coverage, among other information. And you know what? Watch out today. Your assignment one will be graded and the solution will be uploaded. And let me tell you this, the midterm we only cover week 1 and week 2. Okay, week 1 and week 2. But the largest percentage of that we actually come from week 1. I need you to check the announcement section for information, for update, and check the canvas in general for information. Okay, this is where I'm actually going to stop today. Make sure you stay safe and have a lovely day. Bye for now, everyone.